Welcome back to another MATLAB tutorial. Today I'm using MATLAB 2019b and we're going to be looking at arrays. So I'm going to go through some of the basics with arrays, some useful functions on creating arrays and how to index them as well. So in MATLAB a single number is called a scalar, and this is actually a 1 by 1 array, and this means that it has one row and one column. So for example, if we have a variable called x, and that's equal to 4. You can see that variable pops up in the workspace, and we can get a little bit more information about that variable by typing the whos command. Okay, and you'll see for that variable x, it has a size of 1 by 1. So this means one row and one column. Oftentimes we're a little more interested in creating arrays with multiple elements, and we do this by using square brackets. So let's say we wish to create an array containing the numbers 3 and 5, and we wish for that to be a row vector. Okay, we do so by either leaving a space in between the 3 and the 5, or by using a comma to separate the two variables. So if we type whos again, we'll see that x is now a 1 by 2 array, so a 1 row by 2 columns. So I like to remember that as RC for remote control, rows and then columns, 1 row and 2 columns. If you'd rather, you can double click on your variable in the workspace and that'll pop up here in the window, and you can see that this is indeed a row vector. Sometimes we would rather create a column vector, and if you separate your numbers with spaces or commas, you'll get a row vector, but if you separate them with a semicolon, you'll get a column vector, which is an n by 1. So for example, let's say we have a vector x, we want this to have the variables 1 and 3, and this time we separate with a semicolon. You'll notice that x is now a column vector. Again, we can confirm this with whos, and x is now a 2 by 1, so 2 rows and 1 column. Okay, so we can also combine spaces and semicolons to create a matrix. So if we have a variable x, and this is equal to 3, 4, 5, okay, this is going to be a row vector. We're denoting the elements of this vector in terms of a row. And then if we wish to add another row underneath, we simply separate that with a semicolon. So I'm going to recreate x this time, and I'm going to say the first row is equal to 3, 4, 5. And when I put a semicolon, I'm saying please start a new row. I'm going to call the next row 6, 7, 8, and terminate that with a square bracket. And as you can see, we've created a matrix. So creating variables is all very well and good, but what we're actually interested in is performing calculations. So for example, we can create a vector, a row vector perhaps in this example, that contains the square root of 10 as the first element and pi squared as the second element. So we can do this directly. We can say x is equal to the square root, so the square root function in MATLAB is sqrt, and 10. So if you type in a function name and open the bracket, you'll see that MATLAB does a really good job of suggesting what it would like as an input. So we're going to say the square root of 10 is the first entry. Okay, we're in a row vector, so I'm just going to separate with a space. And then I can say pi squared as the second entry. And as you can see, MATLAB will generate the output for you. So arrays are used throughout MATLAB. And so you should recall that MATLAB is actually an abbreviation for Matrix Laboratory. And you'll find that most of the MATLAB functionality can work with multiple vectors, multiple values at once. Okay, so I think the next thing to do is to look at some ways of creating evenly spaced vectors. So sometimes we want to create a vector, let's say x is equal to the values 1, 2, 3, 4, 5. Okay, row or column, it doesn't matter. And so for long vectors, entering individual numbers isn't really practical. Okay, so there is an alternative shorthand method for creating evenly spaced vectors, and this is using the colon operator. Okay, and we only have to specify the start and end points to begin with. Okay, so let's recreate that vector x, and I can say x is equal to 1 colon 5. And this will count from 1 to 5 in steps of 1 and create that as your vector. Okay, you can start from any number that you like and it doesn't matter. And so notice that the square brackets are not needed when you're using the colon operator. So as you can see here, the default spacing for the colon operator is 1, but we can specify what the spacing is that we would like. So for example, we can create a vector x and say that x is equal to 20 to 26. Okay, and let's say they want to go in steps of 2. Well, we have to specify that in the middle. So we say I'm going to go from 20 in steps of 2, use another colon, and type 26. And you'll see this time it has gone up in steps of 2. Okay, similarly, we can go up in decimal increments if we wish. We can say x is equal to 1, 0.55. So this is going to count from 1 to 0.5, or it's going to create a vector, sorry, in steps of 0.5. Okay, and we can also create a row vector in other ways, and the first, or one of the most useful ways of doing it is if we have a number of elements in mind that we want to have in the vector. Okay, so rather than having space in between each element, we could instead use the Linspace function. Okay, so again, if you don't know what a particular function does, you can search the documentation at the top, Linspace, and you can see this will generate linearly spaced of a linearly spaced vector. Okay, and so the way Linspace works is, let's say we want to create a row vector that starts at 1 and ends at 10 and contains 5 elements. We can say x is equal to Linspace. Again, if you open the brace, it'll give you some examples of the input. So here we've got 2 different examples. So we want 5 elements. So the way this works is we're going to go from 1 to 5. Sorry, 1 to 10, I think. And we're going to go, we want 5 elements. Okay, that will make 5 evenly spaced elements in that vector from 1 to 10. Okay, as a default, if we use Linspace without the 5 on the end, okay, MATLAB will create 100 elements. It's a bit overkill for this example. Okay, so both Linspace and the colon operator create row vectors by default. Okay, there is an easy way to convert a row vector into a column vector, and this is to use the transpose operator, which is the single apostrophe. So let's say we have a row vector x is equal to 1 to 3. Okay, and we wish to change this into a column vector. So it's currently a row vector. We want to change this into a vertical column vector. We can simply use the transpose operator. So x is going to be equal to x with that single inverted comma or apostrophe. Okay, so it's oftentimes easier to create a row vector and then turn it into a column vector. Okay, so we can do this as a single command. We don't have to do it in 2 separate steps. So we could say, for example, have a x is equal to, and this time we're going to want to put it in a set of brackets. So 1 in steps of 2 to 5. That's how that would read. And now we can put the apostrophe in, and that's going to count from 1 to 5 in steps of 2, and that's as a single command. Okay, so just remember, you don't need to use the square brackets if you're using the Linspace or colon operators. Okay, so there are some other functions that are quite useful that we'll take a look at. So MATLAB helps you create commonly used matrices, and one of these is matrices of random numbers. Okay, so there's a couple of commands for this, but we can start with, let's say we want a 2 by 2 matrix of random numbers. So we can say x is equal to rand2. Okay, and if we want to see how rand works in a little more detail, again, we can type in rand at the top and the documentation. So the rand function here says uniformly distributed random numbers, and as always, it has some examples. So as far as I can see, I think these random numbers are between 0 and 1. Yeah, in the interval between 0 and 1. So obviously there's other things you can do if you want to change that. And by default, just entering one number will create a matrix. So if we want a 5 by 5 matrix, we'd just do rand 5. Okay, sometimes this isn't useful. Sometimes we wish to create a vector of random numbers. So we can say x is equal to rand. Let's say we want 5 rows by 1 column. You can do that too. Okay. Some other useful functions for creating arrays is the zeros and 1 function. So the use of zeros functions create a matrix of all zeros. Okay, again, if you want to have a look at what zeros does, you can have a look at the top, but the clue is in the name. So for example, if we say x is equal to zeros, 3, it's going to create a 3 by 3 matrix of zeros. And if we'd rather have a vector, we can have it as a vector if we like. Okay. So to get the size of an existing matrix, I've shown you how to use the whos command, but we can also use the size function of x. Okay, and size will tell us we've got a 1 by 6 row vector. Okay, so just a few points now on indexing arrays. So indexing is just another word for manipulating or changing the values of stuff. So I'll load a little bit of data for this for now. So I'm going to load the data file. Okay, so this is an example straight off the MATLAB MathWorks website, so you can use that for your reference. So let's have a look at what the data looks like. Okay, we have 3 columns of data. Okay, we can have a little bit more information about that. Size of data, 7 rows by 3 columns. Brilliant. And you can see that the first element of the final column is not a number. Okay, so let's remove this from the workspace. Sorry, from the command window. Okay, so you can extract any values from an array using row column indexing. So remember I said RC remote control. Okay, so the syntax that we use for this, so I'll just pop data up again so we can see. Let's say I want to create a variable called x that contains the value, the exact value in the 5th row and the 7th column. Okay, well, it's not very good in this instance, is it? Because we've only got 3 columns. So let's say we want to take the second element of the 3rd column. So we can say x is equal to data, the 2nd row in the 3rd column. Okay, and we have 0.1419. Brilliant. Okay, so MATLAB makes life a little bit easier for us. We can also use the colon operator and the end keyword to obtain values at the end of a chain. Okay, so let's say we want to have a look at what the end value is of the 2nd column. Okay, so we can say, let's say x is equal to data. So rows and then columns, I want the end of the 2nd column. Okay, so end is the last one. So if you don't know how big it is, you can use the end. And this will obtain that variable and send it to x. Similarly, we can use arithmetic with keyword data. Now I've deleted it all, haven't I? Okay. So similarly, we can use arithmetic with the keyword operator. So let's say we want the penultimate or the second to last value in one of the columns. We can say x is equal to data. And let's say we want the second to last value in the 1st column. So we can say end minus 1 of the 1st column. And you can see we have this value here. Okay, so it's a really useful way of indexing arrays. Okay, you can also obtain a value just by giving one index for a matrix. Okay, so what will happen is it will traverse down each column in order and give you that number that you're interested in. So let's say we're interested in x being equal to the 8th value of the matrix data. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So this is how it works. It'll traverse down each column in order. Okay, so perhaps more usefully, I'll put data up again. I've cleared it again, haven't I? Okay, so we can also use the colon operator for indexing. So what it means is when it's used as an index, the colon operator specifies all the elements in that dimension. Okay, so if I type in x is equal to data colon 1. What I'm saying here is I want all of the elements in the first column. If I type it in properly. Okay, all the elements in the first column, so that extracts the first row. Brilliant. Okay, and similarly we can go one step further. And let's say we want to refer to a range of values. Okay, we can create a vector from within this matrix data set. So let's call this next variable a again. Okay, and we can say data. And if I said something like that to 3, we're using the colon operator twice here. We're saying I want all of the values from columns 2 and 3. Okay, so this is a useful way of just grabbing a couple of columns, or you similarly could do for rows as well. Okay, and as you noticed already, we've got a NaN, not a number, for the first variable, the first element of the third column. Okay, so we can store or obtain, but we can also overwrite. Okay, so a single range of index values can be used to reference a subset of vector elements. Okay, so that's just a fancy way of saying we can replace this. So let's say I want to access that, so it's going to be data, and it's the first element of the first row, third column, is equal to, and let's say I want to call this 0.5. Okay, you can see we've now grabbed that and assigned 0.5 to be that variable there. Okay, so we can also, just one last thing to clear up, we can also specify particular elements that we'd like to take in. It doesn't have to be consecutive numbers. Okay, so for example, let's say we want to extract the first, third and sixth elements of this matrix. We can say x is equal to, and now we come back to our square brackets, so we can say 1, 3 and 6. Would help if I wrote the right thing, wouldn't it? So x is equal to data 1, 3, 6. My apologies. And that'll extract the first, the third and the sixth element of that matrix. So that's just a whistle-stop tour of dealing with arrays in MATLAB. I hope you found that useful, and I'll see you all again soon.